Okay, so everyone is talking about multi-agent system right now. Sub-agents, agents running in parallel, all of it. But nobody really shows you one. So let's just build one right now live. And then we'll race it against a normal single agent and see who actually wins. Same task for both. Timer on the screen. Here's the task. Research 5 databases, pick the best one for a startup. Let's go. First, the normal way. One agent. It does everything itself, one thing at a time. So it looks for Postgres, then Mongo, then Redis, one after another. And at the end, it writes up a recommendation. It's simple. And this little loop right here, that's the whole story. It waits for Postgres to come back before it even starts Mongo. Then it waits again and again. 5 trips, one after another. Let's run it and time it. Okay, so 9.5 seconds. Remember that number. That's what we are trying to beat. Now let's try to make it parallel. So here's the idea. Instead of one agent doing all 5, we put a manager in charge. And the manager hands each database to its own little subagent. Then it fires them all off at the same time. Think of it like a manager and a team. The worker don't even know about each other. They each just do their job all at once. And that's it. That's the whole trick. This one line. It just takes all 5 and runs them together instead of one at a time. That's literally the only difference between a single agent and a multi agent system. Everything else is the same. Same worker, same wrap up at the end. So let's raise them now. And there it is. Single agent, 9.5 seconds. Multi agent, 4. Same task, same answer. But the parallel one done in less than half of the time. Because all 5 ran at once instead of standing in line. Now look at the token for a second. They are basically the same for both. Hold that thought, it matters. I'll come back to it. But the speed? Come on, that's night and day. And that pattern has a name. By the way, fan out, fan in. You fan the work to the team. Then you fan the results back in. But look, if you saw my last video, you know a demo that only shows the happy path is basically lying to you. So let me break it on purpose. What happens when one of these subagents fail? The model times out, tools error, whatever. See that. One subagent throws an error and the whole thing dies. All 4 other workers, their work just gone. One flaky worker took down the entire team. That's the exact same cascade from last time. So the fix is simple. We don't let one subagent crash everything. We wrap each one. Now watch. Mongo fails, we retry it couple of times, backing off a little each time, and if it still won't cooperate, then one worker just give up quietly. The other 4 finish fine. The manager work with what it got, and you still get your answer. It tries back off, failing gracefully, same reliability stuff as is always, is just per subagent now. So multi-agent faster, and it's tougher. Is it just free then? Nope. 3 honest catches. First, cost. In this little demo, the tokens came out about the same because both versions made the same calls. But that's not how it works in real world. In a real system, every subagent runs its own full loop. Its own thinking, its own tools, its own context, plus the manager passing stuff around and merging it all together. And that adds up fast. A real multi-agent setup can burn way more tokens than a single agent. So really you are trading tokens for speed. Second, coordination. Notice I picked 5 clean separate databases. That was on purpose because the manager's hardest job is splitting the work up right. If it splits it badly, you get 5 subagents all confidently doing slightly the wrong thing. And merging 5 wrong answer just give you one big wrong answer. Third, the worker don't share a brain. Each one only knows about what you handled it. So the manager has to give every subagent exactly the right context and then stitch all their answer back together without them contradicting with each other. That handoff and that merge, that's most of the real work. So here's the rule of thumb. Parallelize the stuff that's independent. Research these 5 things, check these 10 sources, try these different approaches, perfect for subagents. But if it's a tight chain where each step needs the answer from step before it, don't force it. Just keep it sequential. One agent in order, don't split up the whole team to do something that's basically a line of dominoes. And look, if all of this sound familiar, that's kind of the point. A manager splitting work across a bunch of parallel workers, handling the one that failed, merging the result, that's not really an AI thing. That's distributed systems. It's what backend engineers have been doing with workers' pools, jobs, queues for decades. Which which is the whole theme here. Stop treating agents like a magic. Start treating them like a distributed system they actually are. So yeah, that's subagent, one manager, a team of workers running in parallel, results merged at the end. That's how you go from a cute little demo to something that can actually handle real work. If this finally made it click, do me a favor, hit like, tell me in the comments what you would put a team of agents to work on, and subscribe for the rest of the series. Catch you in the next one. Peace.